climate change, vaccines, education. When we make our decisions about how we want to conduct our own lives, but also how we want our society to proceed, what do we base that on? Do we base our decisions on our preconceived notions, or our political beliefs, or on what we wish were true? Or do we follow the evidence? Each of these has their problems. I contend that when we can't follow the evidence ourselves, perhaps we should defer to people who are qualified to follow that evidence. And that means experts. The problem with experts is they're only human, and that's what I want to talk about today. Welcome to the Inris Files, thoughts on pop culture, history, and the human condition from a very specific Generation X point of view. By the way, if you'd like to engage in these topics, whether you agree or disagree with me, you can do so at my free community on the Skool platform. Look for the link to Something Inconspicuous in the description that accompanies this video. So yeah, experts. They're only human. They can get things wrong. They can be bought. Some lie, some cheat. They're susceptible to cognitive biases like confirmation bias, the same as you or me. The experts are experts not because they're always right, but because they have studied a topic or issue in depth enough to presumably have better judgment in that area than your average person with an average understanding of that area. That means we also need to be careful about what experts are expert in when we take their advice. A medical doctor isn't necessarily the best person to ask for legal advice, just as a lawyer is not necessarily the best person to ask for advice on climate change. So yeah, we have to be careful about which experts we place our trust in. And we also need to be careful about making our decisions on the basis of our political beliefs or some other agenda that is intertwined with how we would otherwise make our decisions on a daily basis. And by the way, I am, as usual, going to tell you some stories about this particular topic. But I want to start with climate change because when I was pursuing my graduate studies, I wrote my master's thesis on the topic not of climate change, but of how public policy influenced the scientific community and how the scientific community influenced public policy with regard to climate change. And the thing is, what I found was the science did change over time, but the science that we paid attention to changed with our own basic understanding of how things are and our basic political views about how things should be. And so as a result, in the 1970s, when there were a series of very harsh winters all in a row, people listened to the climate scientists who were talking about global cooling as opposed to the climate scientists who were talking about global warming or, more broadly, climate change. This was influenced, again, by the layperson's understanding of, well, gee, we've had very, very cold weather for the past several years, so clearly these must be the people who are right, which is reasonable enough, I suppose. But this led to a perception then when we started experiencing warmer weather or return to our normal weather in the 80s and 90s, and then slowly started to see things get warmer. It seemed like the climate scientists had just totally flip-flopped in their attitudes, had gone from, oh, there's global cooling to, oh, there's global warming. This is why scientists eventually started talking about climate change. Climate change as a term is still descriptive. It is still describing the same phenomenon. But that phenomenon is not that it gets warmer everywhere or it gets colder everywhere or that everything proceeds on a straight line. It's more like the trends will change over time. And the trends right now are, in general, favoring the idea of more volatile climate, and this is the result of a generally warming planet. The melting of the polar ice caps and all that. The melting of the polar ice caps can actually end up making it colder in some parts of the world, in general, over a period of time, while it'll be much warmer in other parts of the world. Somebody who has spent years studying meteorology, climatology, geology, geography, somebody who knows how to do the research to analyze core samples taken from ice sheets, or for that matter, from the ground. People who have studied this and developed a certain amount of expertise can advise us, and they can explain to us in language that we can understand what they're looking at, what they're observing, and on the basis of their observations, what they think we are going to encounter. But then we as a society have to decide what we want to do with that information. Sometimes what happens is our decisions about what to do with that information, when we hear, oh, global warming is happening and it's probably partially a result of pollution. Well, if pollution controls mean that the price of goods is going to go up because businesses have to pay more because they have to implement pollution controls, and we as a society have to pay more because we have to invest in recycling programs or better waste management or whatever the case may be, we might be inclined to say, well, what do the experts know about global warming anyway? Because really, climate changes all the time, and maybe they're wrong. But that's trying to alter the advice being given to us by people who are experts on the basis of what we wish were true, so that we don't have to think about how to react. Instead, perhaps we should think about how to react and find ways to react that are more copacetic with how we would like things to be. It's just a slightly different shift in how to look at things, but in general, I think it makes more sense to defer to people who have studied how crime works, because dealing with crime isn't necessarily going to be as simple as, well, we should just pass more laws and we should have more police to arrest more people who are committing crimes, then that'll reduce crime. There are a lot of factors that come into how to adjust the rate of crime, and sometimes it can be adjusting other things that don't appear to be immediately related that can bring the crime rates down. So if crime rates are important to you, look at what the criminologists have to say, as opposed to just going by, well, what they're saying means that we have to change how we do things, and I don't want to change how we do things. I just think we should have more cops. I think it makes more sense to say, okay, what do they say makes the difference? And then to what extent do we want to pursue those differences? And to what extent are those the changes in how we do things not acceptable? At the end of the day, experts can only advise us on their field of expertise. They cannot necessarily make the decisions on what to do about it. And I'll give it, if we come back to climate change, for example. The scientists can advise us on the science. And in general, by the way, if somebody presents an argument about climate change, look at their expertise. Are they experts in climate change, or are they experts in something else? If their PhD is in psychology, are they necessarily as qualified as somebody whose PhD is in climatology? But once the scientists have advised us on the science, then let's listen to public policy experts on different ways we might pursue public policy. It's up to us as participants in a democracy to decide what to do about the advice we're being given. But just rejecting the advice wholesale is not necessarily in our best interest. Now, I want to talk about vaccines. And by the way, you'll notice I am not advocating a particular position about climate change. I'm not advocating a particular position about criminology. I'm going to talk a little bit about vaccines, but understand that at the end of the day, the science may change. Actually, more like at the end of the decade, at the end of the century, our understanding of how the world works may evolve as the people who study this get more information, test more hypotheses, and come up with better theories. And my contention is that people who have looked at the evidence should probably be given a little more credence than a bumper sticker slogan that sounds really catchy. When it comes to vaccines, we're already at a disadvantage because there are a lot of people who have believed the research of a research scientist who falsified his data in order to not trust other experts in this field. And I'm talking about an individual whose name is Andrew Wakefield. He was a doctor in England, and he had produced a study that he submitted to a very respected medical journal called The Lancet. And in his study, he established a correlation between measles vaccines and the rise in the diagnoses of autism. And this paper was published. It had been peer-reviewed. And so for a period of time, it was generally believed that measles vaccines could be leading to the increase in diagnoses of autism. Now, over time, and this is the thing about how science works. Science isn't an ultimate declaration of facts. Science is a process of trying to figure out how the natural world works. It's a process. It is not the definitive answer, but it's a method for trying to find an answer that's closer to the definitive answer than just wild guessing. Part of the process of science is once you have established, I have done this research, these are the results I have found. Well, when you publish that information, other people can try the same experiments you have tried, or try other experiments that illuminate the experiments that you conducted to see whether your results are reproducible and to see whether your conclusions are accurate. In the case of Andrew Wakefield's linking the measles vaccine to autism, they discovered that they couldn't reproduce his results. And in fact, not only could they not reproduce his results, they proved rather effectively that there was no correlation at all between vaccination rates against measles and autism. The more research highlighting that came to light, the more Andrew Wakefield's study came to be questioned. And eventually, people discovered Andrew Wakefield had invested money in an alternative medicine scheme, and he was hoping to convince people to use his alternative medicine products instead of trusting in the measles vaccine. So he was motivated by greed to falsify his data. Eventually, the research scientists did establish that his data was falsified. And this was something they were able to look up because in order to be peer-reviewed and published in a peer-reviewed publication, that means you have to present all of the information. They looked at the information and noticed where he had changed the names on some of the samples and had thereby changed the results of some of the experiments or some of the tests. And so as a result, Andrew Wakefield did end up convincing a lot of people that an alternative would be to use alternative medicine remedies instead of the measles vaccine to address the problem of measles. And those people won't listen to scientists who are conducting more reasonable and not falsified data to make their assertions. We're going to reject what the real scientists say because we believe there's a link between vaccines and autism. I'm presenting this as an example of putting your trust in the wrong expert. You're putting your trust in an expert who actually is motivated by greed, and instead you are ascribing that notion of greed to the scientists who are doing the research on the efficacy of vaccines. By the way, there is such a thing as big pharma. There are companies that do make more money if they can convince the general public, or if they can convince the people who are experts to convince the general public that their medicine is better than not taking their medicine. And we have seen this play out. We have seen that there are bad faith actors out there. The corporations behind the pharmaceuticals industry are just as susceptible to corruption as car manufacturers and toothpaste manufacturers. Nonetheless, car manufacturers do still manage to produce increasingly safer and more fuel-efficient automobiles all the time. And pharmaceutical companies are producing reliable medication that accomplishes what it's supposed to accomplish all the time. Otherwise, they wouldn't exist. They wouldn't continue to exist because they would collapse under their own weight. Nobody would trust anything that they say ever, and that would be the end of that. I think it is reasonable to greet the information that is presented by any person or corporation who represents themselves as experts. It's reasonable to greet that with a healthy amount of skepticism. But a healthy amount of skepticism does not mean denial. It means give me a better understanding of how you evaluated the evidence, and then I'll go from there. So I recognize this is a more sophisticated, nuanced, complicated issue than simply saying all vaccines are good. Trust the pharmaceutical companies when they tell you to take vaccines. Or all vaccines are bad. Don't trust medical science. Trust in these shaman who recommend different plants and herbs and rituals in order to rid yourself of evil spirits. I think when you are evaluating the evidence in general, it makes sense to see who else is doing a better job or a more reputable job of evaluating the evidence. I do want to talk a little bit more about vaccines and measles and all that in a little bit, but first, I just want to continue this thought on experts in general. I've told you science is a method. It's not a result. It is a means of trying to figure out what the facts are It is not necessarily the collection of the facts. Likewise, historians are in the business of studying history, and they can evaluate the evidence from history, and they can tell you their understanding of what has happened in the past. And perhaps you can recognize the patterns and then make some reasonable assumptions about how the future will play out. Oh, what do you know? Every time we have done this, we have seen this result. Is this new policy we are entertaining, is it more similar to this thing that has failed every time, or this thing that has succeeded every time, or this thing that has produced mixed results? But we should be paying attention to historians when we are evaluating actions we as a society want to take as a whole moving forward, or we want to take in order to address specific situations. But historians are getting better understanding of history all the time. Scientists are getting medical scientists are getting a better understanding of how the human body works over time. And engineers are getting a better understanding of how the natural world works all the time, which is why they keep refining the technology, for example, of airplanes. I don't know if you have noticed the change over time, but it used to be that the wings on jet aircraft, when you get on a jet to fly across the country, the wings used to they had a very specific shape when you looked at a cross section, but in general they kind of went straight out from the main body, the fuselage of the aircraft. Now the ends of the wings tip up at an angle, at like a 90-degree angle, and they go up a bit just at the very ends. Well, this is because research has indicated that that provides for a more stable flight and more fuel-efficient flight. But this is research that is being done because you don't assume that your understanding now is permanent. You have to acknowledge that we can improve our understanding of how nature works, whether that's human nature or biology, chemistry, physics, whatever the case may be. So I use that as an example, the tips on the wings of airplanes, because that's something that anybody who has been flying for more than a decade or three has seen that change happen in our lifetime. I realize if you're watching this 30 years in the future, well, airplanes have always had that shape of wing. Or maybe airplanes don't even have wings anymore. They have some other feature that enables them to fly. In general, we get our best understanding of reality by looking at both physical evidence and tests that we conduct in laboratories, and then the statistics of the results of those experiments, or the statistics of the results of observations that are made. Even if you can't test changes, you can make observations about changes that happen. In this regard, I'm talking about the existence of dark matter. We know dark matter exists because the gravitational effect on light as it is passing through some areas of the cosmos is different from when it passes through other areas of the cosmos. And we have come up with a term to describe the change in the gravitational pull. Why are we seeing gravitational pull in an area where we are not seeing any actual objects? We're calling that dark matter for the time being until we have a better, firmer understanding of what it is, but we know it exists, and we are increasingly more aware of how it works. This is something we learn from observation. This is not something we learn from experimentation. The thing about statistics, though, is that statistics don't win people over as a general rule. I could spout statistics. I actually did a lot of research before recording this today. I did a lot of research on the history of the measles vaccine. and of how the effect it has had both on the spread of the disease, the fatality of the disease, and how reductions in the vaccination rate have led to a return of the incidence of measles. I can throw all kinds of statistics at you, and eventually, or maybe right from the very beginning, your eyes start to glaze over, and you're like, okay, whatever. Nonetheless, I know this. Some of the people who have continued to carry the torch of Andrew Wakefield's falsified experiments say that, well, they are convinced from their own observation, symptoms of autism tend to start to manifest at around the same time that children tend to be vaccinated for certain diseases. Some diseases you're vaccinated later. In general, you are vaccinated when you are vaccinated because experimentation has determined that that is the ideal time to trigger your immune system to train it to better address this particular disease. Well, if you know that there's a little bit of a correlation between the time that you get your first vaccinations and the time that you start to recognize the onset of autism, you might make the conclusion that the two are related. However, I'm going to give you a piece of statistical evidence that is not hard to wrap your head around at all, and then give you another story. And this is ultimately the issue, is that statistics are not a good place to start. If you're trying to convince somebody that you should this or you should that, starting with statistics is not going to win people over. Usually you start with a story. And Andrew Wakefield's falsified data has continued to carry the day because there have been well-known celebrities who have told stories about how they have come to believe that there's a link between the measles vaccine and autism. And it's that story that hooks you in. And then it's very difficult to come up with the statistical explanations as to why we know that's not true. However, in this case, there actually is an advantage. There is one statistic that I'm going to hit you with that I think you will understand is, yeah, that's not hard at all. If you look at how many people develop autism, the rate at which autism exists, if you compare the population of people who are vaccinated and the population of people who are not vaccinated as children at a young age, the percentage of that population developing autism is exactly the same. So you are just as likely to develop autism if you have the vaccine as you would if you don't have the vaccine. So since you're just as likely to develop autism or not develop autism, regardless of whether you take the vaccine, there can't be any causal relationship between the vaccine and developing autism. So there's a statistic for you. Now, a bunch of experts had to do a lot of research to determine that this is the case. And they have done the research now with millions and millions of children. And the research is conclusive. Now, I'm talking about the measles vaccine. I recognize that there are other vaccines that have had less research go into them, and it's possible the jury is still out. But when it comes to mumps, measles, and rubella, or whooping cough, those vaccines have been proven to be safe and very effective. Safe in that they have no long-term consequences that are statistically significant, But they do have statistically significant results in terms of beating the disease, reducing the incidence of disease, to the point where in the United States, for a period of time, we had essentially eradicated measles in the United States. I want to talk about the year 1912. This is a story. This isn't a statistic. This is a story. 1912 was a bad year for measles. This was the year that the United States started keeping track of people reporting incidents of measles, people being hospitalized for measles, and people dying from measles. And I have the numbers here somewhere, and I don't have them in front of me right now. I think what they came up with was, within the United States alone, 5,000 to 6,000 people on average per year died as a result of contracting measles. Once we get to the year 2000, the effective fatality rate of measles in the United States was 0. Every once in a while, there was a case of a fatality, but it wasn't until 2025 that we started to see the number actually go up in any appreciable way. Fatality, by the way, the fatality rate of measles, some of it is the reason measles has become less fatal. Part of it just has to do with doctors are better at washing their hands and keeping sterile environments when patients come in. They're better at keeping patients separated from each other to reduce the amount of risk of being exposed to the measles when you go into the doctor's office. All of this. But in 1912, measles was such a problem that the United States decided they had to start keeping track of it. And ultimately, by the time they had developed the vaccine in 1963 was when they first started administering it on a widespread basis. By the time they got to that, they had already reduced the amount of fatalities. But even at that time, the understanding was the vast majority of the population had been actually exposed to measles to the point where you could say they had the measles. It's just that our immune system was able to fight it better because of changes in how we were dealing with that and other diseases. Things were not so good in 1912. And it so happens that my family has a story about the measles in 1912. In 1912, my great-grandparents had 7 children. This is in June of 1912. They had 7 children, and my great-grandmother was pregnant with another child on the way. She was 5 months pregnant. And in June of 1912 is when the household was exposed to and developed measles. The kids all got measles, and early July, one of them died from the measles. I've got the name here, and this was Eugene. Eugene was about 3 years old. And 4 days later, his 2-year-old brother, Otto, died. So my great-grandparents found themselves having to bury 2 of their children in the space of 4 days in the summer of 1912. Their little sister, Azalie, she was born in October. She lived for 2 months before she finally succumbed and died. They didn't perform autopsies on children who died young back in those days. The assumption was she had been exposed to measles in the womb, and she had succumbed to measles in early December of 2012 or 1912. So my great grandparents had to bury a third child within the space of just a few months. Fortunately for my family, and especially for me, this didn't stop them from continuing to have kids. They had another 5 children before they were done having children. And the fourth of those 5, so the second to last child that they had, became my grandfather. My father, when he was young, I think he was 4 years old. I think that was the first time he got the measles. He also, and he was hospitalized. He also, as a young child, developed mumps and whooping cough. And then he was hospitalized a second time around the age of 8 for the measles again. Ultimately, they had removed his tonsils because at the time, medical science suggested that that would reduce the likelihood of the disease, any of those diseases coming back. And something else, adenoids, I think, something along those lines. He had a couple of surgeries to remove glands in order to hopefully reduce the likelihood that he would be hospitalized yet again or worse. So when the measles vaccine came out and started being used in a widespread fashion in 1963, my father had vowed that any child of his would be vaccinated against these diseases to the extent that those vaccines were medically viable. So there's a story. And you could do with this story what you will, but the fact of the matter is there haven't been any cases, or at least enough cases, apparently, within the United States, or North America for that matter, of the measles that have resulted in any parents having to bury their children, with 1 or 2 exceptions here or there, for the last generation. And even beyond that, go back 2 generations. It's very rare. I'm Generation X, so essentially 3.5 generations going strong. And my generation hasn't had to deal with measles all that much, but our parents did. So, food for thought. This is certainly an anecdote that has affected my family and my family's attitude about immunization. I will also note that my ex-wife, she is an expert in microbiology. This is what her advanced degree is in. And so when mRNA vaccines were coming out, she was able to talk about the science behind it, what it meant, how it worked, and the fact that they had been actually tested for 20 years before they were actually used on the population. I'm not going to go into the science about it, and I understand that there are some good critical analysis happening now on whether or not the mRNA vaccines should continue to be deployed. I believe I know where that's going to go, but I'm not an expert. You should consult with the experts who have studied this for real when you are making evaluations on vaccines for yourself and your family. Of course, that's just my opinion. But that is the problem with experts. Experts are only human. They are fallible. They will make the call wrong from time to time for whatever reason, whether they're motivated by greed, as in the case of Andrew Wakefield, or whether they're just wrong. But over time, experts tend to get a little better at getting it right. And I think it is worth paying attention to experts rather than making your decisions on the basis of some YouTube video that you watched that convinced you that reptiloids have taken over the political system, and so as a result, we need to vote for the anti-reptiloid party. It's just a thought. Thank you for visiting the Inrest Files. Stories served with some food for thought. Come back again soon. Take care.